We just did the classification of the critical points by hand. I want to show you how you can evaluate these in MATLAB and find the eigenvalues directly from there. So let me go over to MATLAB and let me clear all the outputs here. And now what we're going to do is that we're going to evaluate each Jacobian at the critical points and find the eigenvalues for each. So to evaluate the Jacobian, this is, well, we cleared all the outputs, but we still have them saved. So if you had a section break, you'd have to run the section. So if we run this section, now we have our Jacobian. Now this is a function of x and y, so we can just evaluate them at the critical points, which were 0, 0, and then we had -1, -1, and the last one, if I remember correctly, was 1, -1. Then, to find the eigenvalues of a matrix, you just use the eigenfunction. And then you can assign it a name. So we can say eigen of 0, 0, for example. Eigen of -1, -1, so that you know what each eigenvalue corresponds to in terms of the point. And the last one is eigen of 1, -1. And now we press Control Enter. They don't like this. They don't like this at all. So let's just call him eigen 1, eigen 2, and eigen 3, and then we'll reference the code to remember which one was which. So we see the first one has a negative eigenvalue and a positive one, so this is a saddle. This one has a real part, which is positive, which means it's going to be unstable, and then an imaginary part, which is going to make it spin. So it's going to be an unstable spiral. And this one has two negative values, so this, and they're all real, so there's going to be no rotations associated with it, and they're going to attract, so it's going to be a stable node. So this is how you do it in MATLAB. I wish you good luck on the quiz, and let's kill it.